Okay, so we've got January 2008, Module 4, Question 1, and this was a specific heat capacity question. So we're given a piece of apparatus, so we've got a can which has got milk in it, we've got a stir, we've got a thermometer, it's attached to an electrical supply, so it's an electrical heating method, and the can is surrounded by insulation, and we've got a timer. We're given all of the information that we would require: PD, current, starting temperature, finishing temperature. And so remember, for this here we're going to use that Q is equal to MC delta T. Q is going to be equal to I times T times V, so that's equal to MC delta T. So we need the current, we need the time, we need the voltage, and we're told it's over a 5-minute period. So we've got the time, we just need to be careful. That time is 5 times 60, which is equal to 300 seconds, so we just need to be careful when we're doing that. But that should give us anything that we need to calculate. And in fact, the first part of this is to use these results to calculate the specific heat capacity of the milk. So again, we'll just say MC delta theta is equal to Q, which is then equal to I times T times V. So that means then that whenever we fill these in, we have the mass. We just need to check what the mass was again. So the mass of the milk was 0.126, and we can then say 0.126 times the specific heat capacity, which is what we're looking for, times the temperature change. Well, it went from 19 to 43, so the temperature change is 43 minus 19, and that's equal to, and the current was 3.74, 12.4 in 5 minutes, so that's equal to, filling in our current, was equal to 3.74 times 300 seconds times the voltage was 12.4. So when we multiply all that out, that's equal to 13,900, and so that means C is equal to 13,900 divided by 0.126 upon 43 minus 19. Should have subtracted those really, but put that into your calculator, and that gives us 4590, and that's joules per kilogram per Kelvin. So specific heat capacity of milk is equal to 4590 joules per kilogram per Kelvin. It then says, look in carefully at the apparatus and describe one experimental technique to improve the accuracy of the results that should be employed during this. Well, if you look at the apparatus, now, one of the things here that should be done is that we should stir the milk continuously. Okay, so continuously stir the milk to ensure even temperature distribution. Okay, the explanation then: stirring encourages an even temperature throughout the liquid. Throughout the liquid. So stirring encourages an even temperature throughout the liquid. Continuously stir it to ensure that happens. Alright, then assume that the appropriate technique has been used. State the major source of inaccuracy. Well, the major source of inaccuracy here is no allowance was made for the metal container. No allowance was made for the metal container heating up. Okay, so even though there's nothing lost to the surroundings, the can will heat up, and so what we need to do is calculate. So we need to calculate the heat energy gained by the tin and subtract this. From the energy supplied.